for backing up.
Thanks for the intro. Good afternoon, everyone. I'm Zahra Ashktorab from IBM Research, and I'm excited to talk to you about our work on resilient chatbots, repair strategy preferences for conversational breakdowns. This is work I did with my colleagues at IBM Research, Mohit, Jain, Vera, Liao, and Justin Weisz. So the use of chatbots has become increasingly widespread in everyday life. Most of us in this room have probably had some level of interaction with chatbots, either to make reservations or to book something or for general e-commerce purchase. But sometimes these interactions don't go well in the way that we intend them to go, which may leave us frustrated. So when a breakdown occurs, this might be because the user's query does not map onto the right intent, or there might be no intent defined in the first place. And the user may respond in different ways. They may express explicit dissatisfaction. They might rephrase or repeat what they originally said. They might request a live chat. Ultimately, it leads to the termination of the conversation. And what we're interested in is investigating repair strategies at the point before the termination of the conversation so that we can repair this breakdown. So our first research question is, which repair strategies are preferred when a conversational breakdown with the chatbot occurs, and why? And we look at 8 different types of repairs, which I'm going to go through individually to explain to you how they relate to each other and what they look like. So we use several concepts from communication theory on grounding and repair to drive the choices of the repair strategies we studied. And first, we considered the evidence of misunderstanding or initiation of repair, which we describe as evidence of breakdown. So we have one repair that has no evidence of breakdown, which we call top, and then we have several other repairs that do have evidence of a breakdown, 2 of which are confirmation and repeat, which leads us to part A of our first research question: is it preferable to acknowledge breakdowns? We also distinguish self-repair from system repair, which leads us into part B of our second research question: is it preferable to provide system repair, and is it preferable to provide assisted self-repair explaining a system's understanding? We have 2 repairs that look at system repair, defer, and options, and we have 3 that look at self-repair, out of vocabulary explanation, keyword confirmation explanation, and the keyword highlight explanation. I'm going to go through examples of each of these in the next couple of slides. So in the top repair, the top intent is uttered to the user regardless of the confidence level, and there's no evidence of a breakdown. So the chatbot can be 10% sure of its response, and regardless of that, go ahead and give a response and not show any kind of indication that it's only 10% confident. In the repeat repair, the bot repeats itself after expressing it did not understand the user's request. So there isn't evidence of a breakdown, but there is no system or self-repair. And similarly, in the confirmation repair, the bot clarifies the user's utterance and then confirms the user's request. We also have 2 repairs that have evidence of breakdown with system repair, the first of which is options. So options are given based on the user's utterance. And we also have defer, where the bot defers the request to the human agent. We have 3 repairs that have evidence of a breakdown with self-assisted repair, the first of which is keyword highlight explanation. So here you see add and card are highlighted. And so that is the vocabulary that is understood by the chatbot is highlighted in the user's utterance. In the out of vocabulary explanation, vocabulary that is not understood by the chatbot is highlighted in the user's utterance. And in the keyword confirmation explanation, vocabulary that is understood by the chatbot is highlighted in the chatbot's utterance, so not in the user's utterance. We were also interested in how do different individual and task-related factors impact preferences for the different repair strategies. And so we do this to find out the answer to these research questions, we conduct a scenario study. And we have 3 scenarios: a shopping scenario, a travel scenario, and a banking scenario. 2 different outcomes in which the interaction leads to a successful repair and the interaction leads to an unsuccessful repair. And then we also use the 8 different repair strategies that we've discussed previously. We also collect measures such as social orientation towards the chatbot, service orientation, prior experience with the chatbots, and experience with technology. Participants were recruited on Mechanical Turk. In each task, Participants performed 10 pairwise comparisons between the repair strategies for a given scenario and outcome. Each scenario was presented turn by turn with a 3-second typing indication in between chat bubbles to simulate the interactive experience of the chat. After both of the scenarios were presented, participants were asked to select which chatbot they preferred and to also give an explanation as to why. Scenarios were selected randomly without replacement so that the same participant did not see the same combination of factors twice, and 2 control scenarios were included as attention checks. We deployed a total of 340 tasks on Mechanical Turk, and we filtered out 137 participants who did not pass the attention check. So this yielded a final of 203 participants, 141 of which were male and 62 were female. This yielded about 1,624 comparisons. 88% of these individuals indicated that their native language was English. Other languages included Hindi, Malay, and Tamil. And 61% of our participants had bachelor's degrees, 14% had a postgraduate degree, and others had at least had a high school degree. The average age of our participants was 34 years. So we used the Bradley-Terry model that yields ranking of objects from paired comparisons. And we used Bonferroni correction to account for the number of individual comparisons that we made. And as seen here, the options repair was unarguably the most favored strategy. Assisted self-repairs, so the out-of-vocabulary explanation, the keyword confirmation explanation, and the keyword highlight explanation also were generally favored, with the out-of-vocabulary explanation most favored among the 3. For the rest, defer, confirmation, repeat, and top, the preferences were noisier. And the reason for that is that, as we observe in this figure, is that they were ranked differently with different repair outcomes. So a really clear example here is that with the defer, when the repair outcome is successful, it's not generally favored, whereas when it is an unsuccessful, it's a favored repair. So as said before, we were interested in investigating reasons why people preferred these strategies. So along with collecting preferences, we asked participants to give reasons why they selected one repair strategy over another. We individually reviewed this data and used open coding to extract the themes and open-ended answers. And a few common themes we observed were efficiency, naturalness, politeness, and perceived intelligence, of which I'm going to go through. So repairs that were efficient and required less typing were preferred when users preferred options. Users described the options as being faster and concise, and they liked the fact that they had to type less, and that is why it was one of the most preferred ones. Repairs that were perceived to be more intelligent were preferred. So some strategies increased the perceived intelligence and capability, especially when the agent demonstrated its understanding through the confirmation repair, and also when it proactively assisted repair via explanation. Users felt that the repair strategy was much more intelligent, and that's why they selected it. We also found that participants reject the explanations, so those are the keyword confirmation explanations and the other ones that provided explanations, because they felt that it was not natural enough. And so when participants felt that it was too mechanical and not natural enough, they tended to reject the explanations. We introduced 2 distinct strategies for system repair, options and defer. And as said before, options was favored because it was efficient and required less typing. But users also really liked that they were given control and a way to opt out, given the none of the above option in that particular repair. And also, the status of a breakdown, so whether it was successful or unsuccessful, affected the participant preferences. When a repair failed, the defer strategy was preferred, since a human agent is more likely to be able to solve a more complex issue. And since there was a failure outcome, it was perceived to be a more complex breakdown. But if a success can be achieved through a single repair, participants generally found the intervention of the human agent to be unnecessary. So repair strategies that aid with self-repair by exposing a chatbot's understanding model were generally ranked highly compared to the strategies that provide no evidence of misunderstanding. And the reason for this, we find, is that they provide actionable resources for the user to resolve the breakdown, either by providing undesirable words or helping them with rephrasing. So we also wanted to see how different factors like social orientation towards chatbots, service orientation, prior experience with chatbots, and experience with technology, as well as the repair outcome, whether it was success or failure outcome, impacted the preference for the 8 repair strategies. And so for each repair strategy, we selected all the paired comparisons and built a logistic regression model, predicting whether it would be preferred repair or not by including the individual and task factors as independent variables. So we found that participants with higher social orientation favored the top strategy and were less likely to favor the keyword confirmation, explanation, or options. And so these results are consistent with the notion that people with a high social orientation prefer natural conversations and not conversations that seem more mechanical, which are those like options and the keyword confirmation, explanation. We also found that participants with higher service frustration were marginally less likely to favor keyword confirmation explanation, but more likely to favor keyword highlight explanation. And this makes sense because the keyword highlight explanation has fewer turns, whereas the keyword confirmation explanation requires an extra turn to confirm, which some users deemed as being too cluttered or redundant. Participants with more prior experience with chatbots were more likely to favor confirmation. And again, I think this intuitively makes sense as confirmations are commonly used in existing chatbot services. So when the repairs were successful, participants were more likely to favor top and repeat and less likely to favor defer and keyword confirmation explanation. And we conclude through this that simple strategies like top and repeat are more acceptable if a repair can be achieved more easily, while more complex repair strategies like defer and keyword confirmation explanation, especially defer that requires human intervention, may be more desirable in a more difficult repair situation. Our results allow us to consider different design recommendations for repair strategies. We found that acknowledging misunderstanding with forthrightness and less redundancy is important. Our participants preferred repairs explicitly when they acknowledged a breakdown, but they complained sometimes when there was a repetitive acknowledgement as being cluttered or redundant. So we recommend having alternative messages for acknowledging misunderstandings while carefully setting uncertainty thresholds so that these acknowledgements do not appear overfrequently. We also found that it's really important to explain models naturally, aesthetically, and effortlessly. So UI elements such as highlighting can be a powerful tool, but we should be really careful about how we embed these in the conversations so they don't appear to be mechanical and natural or visually unappealing. We had some instances of participants reporting that the highlighted keywords were hyperlinks, and they thought that they were hyperlinks, so they attempted to interact with them in that way, and they found that visually unappealing. Giving the user control is important as well. In the survey responses, some participants noted that the none of the above option provides an explicit way out or a reset button, which they felt gave them more control of the situation, which they really liked. And lastly, we observed that the preferences for repair strategies are not universal. We can leverage the interactivity of an agent system to adapt to individuals and contexts through data or feedback-driven approaches. Thanks for listening to this talk, and I'm open to questions now. Thanks.
Thank you, Zahra. Any questions in the audience? Just raise your hand.
Yeah, thank you very much for the talk. I'm curious, so you use survey instruments to figure out some information about your users as a way to predict what kind of experience they want. So in a commercial setting, where would you get that information? Just several minings, several sessions with these users, or how would you get that information?
I didn't hear the last part of your question, sorry.
Yeah, when you are trying to get information about these users so you can attach or predict what experience they want, where would you get that information in the commercial setting where you aren't asking them surveys before they engage with your chatbot?
Sure. I think there are ways. I mean, at first you'd have to be able to collect the prior ways that they interact with the chatbot. So we'd have to, it wouldn't be something that the chatbot would know how to do right away, but I think by monitoring how the individuals interact with the chatbot, it can then adapt.
Any other question? I noticed that the scenarios were kind of focused on transactional chatbots environments. Do your findings, how do you think they would apply for social chatbots?
Yeah, that's a really good question, and I think the repair strategies might look different with chatbots that don't look at these transactional types of interactions. I think a future study that looks into that would be able to uncover an answer like that.
Yeah, Dan Cosley, Cornell, I really like that question about the socials versus the task-oriented chatbots. But I am curious about whether part of what you're seeing is because chatbots are super new, right? As people get better and better mental models of how chatbots work, presumably their understandings of, what a chatbot can and should do and their ability and willingness to repair them might change over time. I realize that is not your study, so I'm asking you to enter the realm of pure speculation. But I would love to hear what you think about, how you think these preferences might change based on doing the study and other work you're doing in the space.
I didn't hear the last part of what you said. I'm sorry.
I said it would be really cool to hear you speculate a little bit based on sort of this work and any other work you've been doing in the space about how you see these preferences maybe changing over time or what would influence how it changed.
Sure. I think that's a really good question. I think another limitation of the study was that it was a scenario study, and it would be really interesting to see how people actually interact with transactional and social chatbots out in the wild. I think while users were able to tell us about their preferences, we could kind of uncover a lot of more detail about the types of ways that they interact and respond when an actual breakdown happens in the wild.
Any last question before Isaac can maybe start setting up?
Nope.
Thank you, Zahra. Let's give it another close.